So data transformation for non-numeric categorical. So scaling is applied on numeric data. Scaling is applied on numeric data. For non-numeric data, we discussed there are two processes. Basically, what is our data? Object calls. This is our data, which is in the form of, the data is in the form of text. Remember in yesterday's session, we split the data into numeric calls and object calls. Yeah. Numeric separate and non-numeric separate. Now, this is the object calls or non-numeric categorical calls. Now, we cannot have text in data while building a model or running an algorithm. Algorithms don't take text. So what we have to do is we have to dummy encode them. Dummy encoding means assigning numerical identifiers to these levels in the variable. 0 to n levels. Starts with 0, goes up to n levels, alphabetical order. Now, if you look at the first column, item fat contain, low fat and regular. L comes before R, right? So, low fat will be assigned 0, regular will be assigned 1. If we are doing label encoding. So, label encoding, we'll do it in the same column, 0 to n levels, alphabetical order. From sklearn dot preprocessing label encoder. LE is equal to label encoder null brackets. Object calls underscore is equal to obj calls dot apply LE dot fit underscore transform will fit the convert it into label encode. So dot head. Now you can see here text data has been converted into, which is nothing but numerical identifiers being assigned to the levels in the categorical variable starting from 0 to n levels. Dummy encode text data. We must dummy encode numerical categorical data. You will also see numerical categorical data like rating scales. 1 rating, 2 rating, 3, 4, 5 rating will be there. Na? Rating 1 is the lowest, rating 5 is the highest. We can't treat them as equal. So we have to treat them as categories. So that data also has to be label encoded. Sometimes you have rating scales 0 to 10 or 1 to. Sometimes already dummy encoding is already done. Still we have to do the label encoding. Already 0, 1 male female is already done in the data, but still we need to label encode them so that the algorithm recognizes them as categories, not as numbers. What error you are getting? Read out the error in the last. So you didn't give brackets next to label encoder. Did you give brackets next to LE is equal to label encoder? That is a problem. Missing argument means you didn't complete the function. So every function, null brackets compulsorily. Otherwise, you'll get the position argument. Missing argument error means you have forgot brackets in the label encoder is a predefined function. Now, the second method of encoding is get dummies. PD dot get underscore. This is also a very important thing, particularly in regression algorithms. We prefer get dummies rather than label encoding. So, particularly in regression algorithms, the categorical variables to be done using get dummies. Object calls underscore dummies is equal to PD dot, PD means pandas library, dot get underscore dummies object calls. One important thing is object calls underscore label encode dot shape. 14,204 rows, 7 variables. 7 non-numeric variables were the label encode shape. Now look at this 42 columns it has created. For every level, for every category, for every group or class in the categorical variable, 1 column will be created. And binary encoding. 0 means no, 1 means yes will be used. Now let us see the shape of the data. You will understand what exactly. Now, in label encode, fat content 0 and 1. Low fat is assigned 0, regular fat is given 1 in the same column. But what is getDummies doing here? It created 2 new columns. Item fat content low fat, item fat content regular. And using binary encoding. Binary encoding means 0 is no, 1 is. So, binary encoding is used. Binary encoding where 0 represents no and we have different types of baking goods. For every baking good, it created a column. See, breakfast, can, dairy. Similarly, outlet types, we have different outlets. It created 1 column for each outlet type. And look at the 5 item codes we have created, na? DR, FD, and then C. 3 columns are created and binary encoding is. So get dummies will expand the number of columns, whereas label encode will do it in the get dummies will expand the columns. For every level, 1 column will be created and binary encoding is used. 0 means no, 1 means yes. Okay. So get dummies and label encoding, the 2 different types of encodings we can use in our data. There is one more thing called one hot encoder. Nowadays we are not using, but some interviews they're asking one hot encoder. It's better to compare it with label encoder. I think 100 encoder, get dummies are all same. Both of them are same. Additional columns will be created. In one hot encoder also, additional columns will be created based on the number of levels. Let us implement that also to see what exactly it is doing. From sklearn dot preprocessing one hot encoder is equal to one hot encoder. Object calls underscore one hot is equal to dot apply one hot dot fit underscore transform. One hot dot fit underscore transform pd dot data frame object calls underscore one hot columns is equal to. So it is doing in a single format, single column or single array. It is doing it as a single array. It will do it as a one hot numeric array. Okay. In get dummies, we get it as a data frame, separate columns in a data frame format. Here it is doing the same process, but in a array format, single array. So if you look at the shape of the data, everything is coming in one column, right? One single array. One hot encoder will do it as one single array. Now our pre-processing is done. We have to concat object calls. Now we have 2 different data frames, right? One for numeric calls and one for combined df underscore clean is equal to pd dot concat num calls underscore standard scale object calls underscore dummies comma axis is equal to 1. Earlier we used row concatenation. Here we are using column concatenation. First it will paste all the columns of numeric calls. Next to it, it will paste all the columns of object calls. In the earlier case, indexing problem. Is this we're getting this indexing problems? Calls standard scale is equal to num calls standard scale dot reset index. Object calls dummies is equal to call dummies. So what it is saying is the column number, row numbers are not matching. That is why it said index mismatch error. So once we reset the index, we will get the new data frame. So column, first it will paste numeric columns. Next to it, it will paste object calls. I think index column will be added again. Index came 2 times. Typically in multivariate data, we go with basic scalar. If standard scalar is not working, then we'll go over min-max scalar. Typical multivariate data, we will go with standard scalars only. But you can also use min-max and robust also. Other things also can be used. Yeah, see, when you are putting it in algorithm, the algorithm treats them what we call matrix calculations happen in regression. What we call when you're calculating inverse matrix and all, the size of the number is not important. It doesn't matter. If you remember the matrix calculations, the determinant of a matrix, AD minus BC, matrix multiplication, you multiply row with column. Now we will split data back to bigma train underscore df is equal to combined df clean square bracket combined df clean dot item. Oh, I think item outlet sales is not there. You have to add the dependent variable. Combined df underscore clean square bracket item underscore outlet underscore sales is equal to combined df dot item outlet. Yeah, indexing issue again, indexing issue. So we are adding the dependent variable. We are adding the dependent variable back to data frame. वही अरे कल आए थे ना 2 टन फिट करने के लिए, वो 2 टन ऐसे फिट किया ना कल. वही उसी में 1.5 मैंने पूछा ना बेडरूम के लिए कितना चाहिए. वो 1.5 मैंने ले लिया, उसको फिट करने आना है. ब्रैकेट उसका है ना. एक है ना नए वाला का ब्रैकेट. ये 1.5 टन है, बेडरूम में फिक्स करना है. ठीक है. ओके. वो विंडो अनइंस्टॉल करना है. विंडो ऐसी है ना, उसको निकाल के ये स्प्लिट लगाना है. ठीक है, okay. Duplicate double indexing. Add करो, मैंने reset किया ना both indexing. You see there, line number 76 and line number 78. Sorry, cell number 76, 78 add करो. Combine DS के बाद, before dropping, वो सब हो गया, ठीक है. हाँ, इससे पहले दो cell add करो. Then reindex both combined DF underscore clean and combined DF. See, don't run it again and again. Levels will exist will come. It will add more levels. If you run this command, it will, how many times you run it, it will add that many levels, index levels. So if you run only once, okay, go to cell, run out. Let the data be imported properly and it should be run only once. Don't run it multiple times. Indexing should be run only once. Otherwise, every time you run index, it will create one more index again. Okay, indexing is done now. After that, you have to come, you have not combined, right? You have concatenated the data frame, CDF clean. Okay, now drop the index. 73 hours, you can start running. Whatever. It is not defined. That means you have given some other name. What name you have given? Label encoder. Object calls underscore dummies. You didn't run it. You type where are the numbers. No, it is what you call it. Warning. Not axis is equal to 1 here, not 1. See, axis is equal to 1. You have to define the axis correctly. Is not defined. That's why I'm asking you to use tab. Tab will autofill that. Use always tab. Autofill, you will not make a spelling mistake. So in this place, we are using the condition is equal to test, not equal to test. Not equal to test means numbers. Equals to test means we have added the column in the top. For concatenation of data frames, we have temporarily added the dependent variable. See, we have temporarily added the dependent variable item outlet cells to the test data and filled it with the word test. All the cells in that particular column will be filled with the word test. Item outlet says actual numbers are there. Okay. So now we are using the same condition here. To not equal to test means numbers. Equals to test means whatever row has the test word, that row will be taken as test data. Now we will drop that column from our test data. Bigma test df is equal to Bigma test df outlet underscore sales, comma, axis is equal to 1. You drop the column which we added initially for concatenation of data frames. We have added the data column. Now we are dropping it from our test data set. So we got the data back to the normal original structure with cleaned and pre-processed. We got the data back to train and test. So this is the process you need to follow. Whatever data we are going to work in future, this is the steps and procedures you need to follow. After cleaning the data frames, you will have this index problem. So don't forget to reset the index, and resetting index will create a new column called index in our data. Drop that column index. It will create reset index will create a index column. You have to drop it. Okay. Which is nothing but row numbers. Row numbers are bought from the corner to a separate column will be created. Okay. So that you drop it. So after that, you will be merging the data frames and then splitting them based on the test and equal to test and not equal to test. If you do this process 1 or 2 times, you'll get adjusted to it. No problem. Now we'll split our train data into dependent and independent variables. Small y represents the dependent variable. Capital X represents the independent variables. Y is equal to Bigma train underscore df dot item outlet sales. Capital X is equal to Bigma train underscore df dot drop the dependent variable. Y is equal to y dot as type histogram density curve. Plot it and interpret. మీకు ఎట్ సైడ్ కావాలి వాళ్ళు పెట్టేసి వెళ్ళిపోతారు. ట్యూబ్లైట్ కావాలంటే మన తర్వాత ఈ మధ్య అది అంటికిచ్చేది వస్తుంది, అది పెట్టుకోవచ్చు ఇటు సైడ్కి. ఒకసారి మమ్మీకి ఇవ్వండి. ట్యూబ్లైట్ దగ్గర పెడితే ఓకే కదా? ఆ ట్యూబ్లైట్ దగ్గర పెట్టేస్తే ఓకే కదా అంటున్నా. అడుగుతున్నాను నిన్ను. అయితే అతనికి ఫోన్ वही वो ट्यूबलाइट के नीचे लगा दो. ट्यूबलाइट निकाल दो फिर. ठीक है, वही रख दो. वही लेफ्ट में है ना? उसी में इसमें बता दो. और वो स्टैंड उसका यूज करो, कल आया था ना जो स्टेबलाइजर नहीं है क्या? जितना भी है अब लगा दो, वो बिलिंग दे देंगे. There is some text data somewhere. See, you have TSP, right? When you're splitting, what you're using. Got it, all of you? So what is your interpretation? What's first skewness? What is the skewness? All the bars are onto the left side, positive skewness. Even the box will be onto the left, right? Y dot plot kind is equal to, comma, what is equal to box onto the left side, outliers onto the right side. Positive skewness and positive kurtosis. Positive skewness and positive kurtosis. So to correct this, we can do logarithmic transformation. But it is making positive to negative skewness. See, if you do logarithmic transformation from positive to negative skewness, it is there. And outliers will be there in this data because some stores will have good sales, some stores will have bad sales. We can't help it. So we will keep the outliers as it is. Density and box plot. All of you got this? Box plot, density plot, positive skewness and positive kurtosis. And even if we do logarithmic transformation also, it is not working. From positive skewness, it is going to negative skewness. So it's better not to transform the data. Train underscore DF. Test null, the average item underscore outlet underscore sales of item underscore fat underscore content. First do the group by. Average item outlet sales of item fat content equal. Oh, I think Big Mart and DF, we have split the data, right? Dummies? Yeah, it's use combined DF. No, combined DF also we can't use. No, we can't use combined DF also. No, we can't do hypothesis testing on this data because we have dummies data, right? If we have label encoding data, we can do. Okay, no problem. We'll do it on some other thing. But this is the process. Now our data is ready to build a machine learning algorithm. Once you have to bring the data to Y and X, that's all. You can run any machine learning algorithm. Bringing data to that shape of Y and X is the biggest challenge. Once you get the data in the proper shape, Y and X, you can run any machine learning algorithm. But bringing that data to that shape without any missing values, without text data, without any other errors and other problems is the most challenging task. So we can just build a model in seconds. A linear regression model will be built in a seconds, but bringing the data to the shape and cleaning up the process is the challenge, which is what we will be spend most of the time in real-time data science. I think we can do using Big Mart train. ANOVA we can do. We can't do t-test. Outlet sales and outlet type, 3 categories. There is no variable with 2 categories. So we can do only ANOVA. So this is the process which we need to follow in doing the data cleaning. So yesterday you asked, no, somebody asked for, can we do it in one single step? The replacement of this thing. I told you, somebody asked yesterday, not we were doing the replacement of low fat LF to low fat, reg to regular, 2 different steps we're doing. But if you want to do it in single step, you have to first create a mapping like this, and then you have to do all the changes in one go. Mapping, we call it as mapping. In mapping, we use dictionary. This is a dictionary, right? Okay, using dictionaries, you have to map and do it. So here we can do any number of things. So this also we will do. Okay, I've sent you a data set, which is women's clothing data set. You can open a new Jupyter notebook and import it. It is also a challenge of pre-processing. I've just sent you the email. Use difference in train and test. How come we have difference in train and Achha, unnamed zero sum columns are there. Or when you get the file, I think there is some other data also in the file. There is no other data in the file. Now we got the correct data. You also got that unnamed columns, right? Now drop them. Find the missing values in train data and test data. Open the previous notebook, keep the notebook open. Keep the other notebook open. Find the missing values. So we have one missing value in price, one in season, one in neckline, one in sleeve length, 55 in waistline, material, many are there, fabric type, many are there, decoration, many are there, pattern type, many are there, area and recommended. Recommended is the dependent variable, which is in the form of 0 and 1. I have sent you the data dictionary also. You can look at it. The data dictionary also I have sent it to you. So the recommendation, whether the product is being recommended or not, 0 or 1, that is the dependent variable. And rest of the variables, pattern type is solid, animal, dot, leopard, decoration, applique, beading, bow button, cascading, crystal, draped, embroidery, material, wool, cotton, mix, fabric type, chiffon, dobby, popline, satin, knitted jersey. So there are different types of this data dictionary is also important. Okay. So check if the values in test data. test df dot info. Almost similar variables have missing values. Almost similar variables have missing values. So what should we do? For combining the data frame, what we should do? We should add the dependent variable temporary to test data. Because test data does not have recommend, na? See, test data does not have the dependent variable. In train data, you can see here, 14th variable is there, the dependent variable, which is in the form of 0 and 1. No 0, yes, 1. But if you look at our test data, there is no dependent variable. For the purpose of combining or concatenating, equal columns should be there. So we have to add the dependent variable temporarily. So let us do that. Temporarily dependent variable. What is the name of the dependent variable? It should be exact name. You can copy from here. Recommended test data. So test df square bracket single quote recommended is equal to single quote test. I am filling it with the word test so that we can use it as a condition for separating the df is equal to pd dot concat square bracket train df comma test df comma axis is equal to 0 row concatenation, row wise concatenation, combine df info. Are not found in the train data, then you can add a cell in between. You might have done it 4 times. There no, you also, there might be no train data got info. This is actually copy from here. That is the problem. Copy from there. Copy one and then change the number. And then two, square bracket by equal to axis equal to 1. Columns axis is equal to 1. Each close here. Okay, 4 o'clock we should take the break. And I will later remember. I copy it out. After you ask the delete chesi double कोई वीडियो मिस नहीं है ना लेबल एंड फोटो అది చేశారు రిడ్ డు ది because done is tailored okay and the column this is purely for data reprocessing. Underscore keypad ఒకటి underscore keypad ఒకటి తీసుకుంటే 4 bit calls. When we tap up ఇదే ప్రాబ్లమ్ అలా కాదు నిర్ణయం చేయాలంటే ఈ కాంప్లెక్స్ ఫైల్ డౌన్లోడ్ లాస్ట్ ఈ పాత మీరు వాడాలంటే Hey, all are object except price, right? Price is also object. How come? Rating, float, right? Yeah. Okay, rating is the only numerical data point then. So, object calls is equal to combine df dot select underscore d types include is equal to square bracket single quote, because there are many object calls here, right? All the object calls data type will be taken into one, select underscore d types. Num calls is equal to combine df dot rating. Only one column in thing, right? If you want all the numeric calls, select underscore data types include is equal to np dot number. If you want to select num calls, because here we have only one num call, but in reality we'll have both large size, right? So you can also do like this, combine df dot select underscore d types include is equal to np dot and float. Np dot number will select both int 64 columns and float 64 columns. Okay, so generally select underscore d types is a function we use for selecting columns based on the data type. So I am writing it in hashtag because in future you will be using this. When you have many numerical columns, then we can't select them manually. In the next data pre-processing example, which we will do sometime next week, where we will work on Kegel house price, where you have 45 objects and 36 numeric variables. So there you can't go and select them manually. You have to do select based on the D type. Select underscore D types. Mapping kelpir 1 second, we will do that. Mapping better, but 1, 2 me try change as a practice. As a practice of replace command, 1, 2 you can try. 1, 2 just try them. Larger ones I will show you how to do using mapping. 1, 2, 1, 1 just for your practice of replace command. Or we'll do the mapping. Just let other people also do it. We'll do it. I have not done missing value imputation. Let me do the missing value imputation. Object calls dot columns frequency is equal to object calls square bracket call dot value counts is equal to false. So first variable no missing values, right? Style there are no missing values. Price has missing values 2. Size don't have missing values. 2 missing values in season. Sleeve line missing values are there, right? Sleeve length. 87 missing values in waistline. 128 missing values in material. 266 missing values in Big missing values are there in 109 in pattern type. So what did you do with the missing values? Most frequent, huh? But one variable has a problem, no? So waistline we can add it to natural, that's okay. But what about 128 missing values in material? We have to add it with cotton. No, missing values of cotton, fabric, material, 128 are there. If you are doing most frequent, cotton will become 280. So shall we keep it cotton or should we keep it as missing only? We should keep it as missing only, right? So write down the variable name. Variable name is material. In the variable material, we'll keep it as missing only. And see, 266 missing values are there in, so we can't impute it, right? We have to keep it as missing only. So fabric type also we have to use the word missing because we can't, that is the most frequent. Missing itself is the most frequent. So in material and fabric type, you have to be very careful. We have to use the word missing. Even in this case, decoration also 236 are NA and NaN. See, very large missings are there. Decoration, material, and fabric type. Even pattern type also we have a lot of. So what should we do with this? So for this purpose, let us evaluate the missings first. All of you have run the value counts. Now let us understand the percentage. Combined DF is null dot sum dot sort underscore values is equal to false. Big missing values are there. So is null to find the missing value. Sum will total the missing value. Sort will give you the descending order sort. If you want to know the percentage, combine DF dot shape square bracket 0. In percentage terms, ఏం పెట్టే స్టాండ్ నిన్న వచ్చిన దాంట్లో ఉంది. నిన్న వాడలేదు కదా, అది వాడమని చెప్పా కదా. ఎట్లా పంపిస్తారు? అది 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 ఉండాలి కదా మన దగ్గర. వాళ్ళకి ఇవ్వడానికి లేదు, దాంతో వేరే స్టాండ్ ఉంటుంది. అది మీరు అనవసరంగా వాళ్ళకి స్టాండ్ వాళ్ళు నేను తేవద్దని చెప్పాను, ఉంది కదా అని. సరే పాత స్టాండే వాడండి, ఇంకేం చేస్తాం. హలో भैया पुराना स्टैंड फिट हो रहा है क्या? हाँ, तो वो स्टैंड है क्या आपके पास? तो आप लगा दो, जो भी है आप वो नया स्टैंड ला के लगा दो फिर. हाँ, वही बोल्ट डला के डाल दो फिर. हाँ, डाल दो फिर. These three okay, waistline we can do cotton. Sorry, waistline we can do the one with the 170 less than 20%, right? But other 2-3 things, what we will do? We can't. They are the major missing values. They are the major missing values, right? So we have to use the word missing only. For this also we will use missing only. I think that is better, right? It is still less than 70, but they are the largest categories, na? They are the top. Relatively, see, they are the biggest category. Missing itself is the biggest category, right? If you see here, the problem is missing itself is a large category. See, the biggest category is missing itself. So how can we impute it? So we have to keep it as missing only, right? When it is third or fourth, then we can do it. Like how we are doing here, we can look at this one. See, 87 is there. So we can impute it with, this is what waistline. Okay, waistline we can impute it with natural. But these four, the problem is the missing values itself is the largest category. So we can't impute it. We don't have the data to do that. Or we have to do an algorithm based imputation and see whether the algorithm might also be right or wrong. It can also be right or wrong. Okay, so for the time being, let us keep this as missing only. Calls is equal to square bracket, single quote or double quote, single quote or double quote, decoration. So these are the missing calls. Per call in missing calls column, object calls square bracket call is equal to object calls square bracket call dot fill NA. We'll fill it with the word. Now just let me check if it worked or not. I'll run the previous one. Oh, combined DF na. So this is sorry. See, all the missing values are gone. Now there are no missing values. So first create a list of all the variables where you have the missing calls. And then I ran a loop where we are filling the NA with the word missing. Direct. All four variables one go. In each iteration, it will fill the missing value with. For remaining also, do it simply. For call in object calls dot columns square bracket call is equal to object calls square bracket call dot fill NA object calls square bracket call. 1 second, let me just check. Yeah, all the missing values are gone. So IDX max is a function identifies the category name of most frequent. So first it will do the value counts. You get the table, right? Categories and numbers. And most frequent numbers, category name, it will take index max. IDX max means index max. So index max means the name of the most category will be imputed in the place of missing value. So IDX max will do the most frequent. Anybody getting the errors, please don't hesitate. Bags are packed, ready? You said no, daughters are throwing you out for not for disturbing them. So we'll look tomorrow, right? We can leave tomorrow morning. No, my class will go at 6 o'clock. So in this loop, only the columns that have missing values will be touched. If the column doesn't have missing values, it will not touch that. All of you are done with missing values? You're done or scroll down? So once you're done, take a paper and write down the duplicate levels in each variable. What all duplicate levels you have? Write down on a piece of paper. Where you have printed the value counts, no? So you can run this command again. You run this command again. In the first variable style, do you have any duplicate variables? Duplicate levels? In style, we have any duplicate variables? Duplicate levels? No, right? Style does not have anything. What is it? Casual, party, bohemian. Price we have, right? What we have in style? One is there, no? A paper is there, pen and I have a pen. Huh?
Like we are doing duplicates first, then we go for this. Can you do like
Which, you can do duplicates also first, and then you can do that also can do.
you're following that?
But the best practice is first missing values and then duplicates. Best practice is first missing values, then duplicates. You can do other way around also, nothing wrong with it, but best practice is there. No? First deal with missing values and then go for duplicates. Small you can do manually. Major ones within a particular thing, that's the problem. Small ones you can do normally with replace. So we can do first is what style, right? Object calls dot is equal to object calls dot style dot replace. One small you can do manually. The bigger ones you have to write a loop. Hey, you are done with that other one. Then do this. This is a follow-up.
Stadium has so many duplicates.
That's what sleeve length we have to do with that mapping only. So in price, low and low, high and high, right? For price also we have done low and low, high and high. Now next is S and small is capital S. S, small s and small is. So we have to add these two to capital S. Dot replace open bracket, square bracket, single quote small s, comma small capital S. Just let me check once, then you can do. Yeah, it is done. Madam, repu 9:30 ka 10:30 class? Okay, ma'am, right. 9:30. The next variable is season. Summer small is there, that will add to capital S. Spring small is there, that will add to capital S. Winter small is there, will add to capital S. Auto AUTUMN, we will add it to AUTUMN. So we will use the mapping here, right? Underscore map is equal to curly brackets. Now single quotes, colon, winter. Comma is there. Yeah, comma is there. Sorry, I forgot comma. There is a comma here. You can write here only. Comma, R, then comma, AUTOMN, right? Which is AUTU object calls dot season is equal to object calls dot season dot replace regex is equal to true. Season underscore map, comma, regex is equal to. Now I'll go back and check once. Let me check. Then I'll show you the code. So this is the process of doing multiple levels in one go. Sorry, read na RWB. You have in programming na RWB. Read, write and read, write and binary is there na. So you can use mouse also for copy pasting. If you're not comfortable with touchpad, use mouse. Copy pasting. Now here also you can copy paste the names from top. You can copy paste the names from top. If you are not comfortable with spellings and all, use copy paste. Control-C, Control-V from the top. And also good keyboard. Tab should work. Otherwise, it will get a lot of problems. Get a keyboard. Or you can do one thing. You can ask them if they have any spare keyboard. Ask Rajshri there. Okay, anything you there, you can use and give it to them back. because that will solve a lot of problems. Hey, what happened to your MySQL? It's going on. You're able to do the things. Okay, no problem. But you're able to get the. Keep the ER diagram ready. Without ER diagram, you can't do. Small Prison map is done now. It should be object once, right? Okay, problem corrected. Use the same process on the next variable. I think next variable also has multiple, na? Rice. Season over. Now next one is. Next one. O neck, V neck, slash neck, both turn down collar. Open, hook. Only sweetheart is there. Anything else? O neck is also open neck. So sweetheart, open is O neck, sweetheart, only two are there, right? Okay, copy this. Control C, Control V. What is the name of the variable? Neck underscore map. Whatever it is, we are giving the name. It's better to copy the name from here. Sweetheart, H capital or small letter? Rest of the things you can remove. Object calls dot neckline is equal to object calls dot neckline dot replace neck underscore map comma regex is equal to copy the previous command down and correct it. Okay, Control C, Control V. So we have it split. Okay. So like here in this windows, everything will get single post. So all the unequal then finally call give the original. Whatever is the multiple, see 3 quarters, now you are saying 3 quarters. Or straight line. Okay, above your enter key. Thrust quarter, 3 quarter is 3 quarter. Sleeveless, sleeveless, sleeveless is sleeveless. And undown color is turned down color. Half is half sleeve. Cap sleeve is cap sleeves. Till now we are dealing with only one option, right? Here we have multiple things. So see, different types of sleeveless spelling mistakes are there. Ultimately, it is only one sleeveless word. Using OR symbol, the straight line symbol below delete, shift and below delete, you have the OR symbol. You try it, no problem. You can try it at home, no issues. You have time, try it, or we'll do it tomorrow in the class, no issues. See, the thing is, we have to go, all of you must be comfortable, and these are the basics. This is what you will be spending hours when you join data science things, cleaning up the data. And you will not be doing it alone. They will break the data into teams. So you will be working in certain variables. The other team will work on certain variables. So data will be split. So in teams you will work. So you might get only categorical variables. The other team guys will work only on numeric variables. Once the cleanup is there, all the data will be merged and it will be given to the data scientist for working on the model. And see, the problem is every time we can't write a Python program. That is another problem. In data, we can't write Python program for pre-processing for everything. So some of them have to be done manually. Manual corrections have to be done. The pre-processing guys will come into picture. So programming cost, again, it's a different thing. So company says, don't programming, you only do manually. We'll put it into the, sometimes we'll do using only Excel only. I have seen people working with only Excel and CSV files, applying filters, VLOOKUP, HLOOKUP, VLOOKUP, right? VLOOKUP and getting the data, particularly financial data, guys. Dates won't match. Stock market dates will not match. If you're trying to do BTC versus stocks, BTC works 24/7, 365. Stocks Monday to Friday only, right? Obviously, date mismatch will be there. So you have to match the BTC dates with Bitcoin dates with and remove those weekend things from this thing. So there are a lot of things which you might still work on Excel also manually using VLOOKUP. Date sparing we still do with VLOOKUP only. That is the best way to do. Now date sparing can be done in Python also. We have pivot and pivot function has come newly. Pivot, unpivot, melt, and all those things are there. But why to use these things when you can do it in seconds on? Read. You have to constantly read and update. See, you should have that interest to read, and also that will give you career growth. If you don't read, I am happy with what I am getting it, career growth. So people who are doing additional things and doing good work in your previous batches, they are growing faster. Some people are attending analytics with their weekends. They do this cloud-based things. You attend them, listen to them. What is there? If you have time, 1 hour things happen, no? Talk about AWS, Azure, cloud offerings, and all those things. Listen to them, or you can find those recordings on YouTube. Some additional knowledge you have, you will get more money. If you say you know Azure and AWS, your salary will be hiked by 2 lakhs. It's as simple as that. If you have a certification, 3.5 lakhs hike. for a person who doesn't have that. That is what they're giving you, because your skill sets will be up now. It is all now what is happening in industry, skill based payments, particularly in data science. I know only Excel, 2.8 to 3 lakhs. Excel plus Power BI, Excel plus SQL plus Power BI, 4 lakhs. If you know Excel, Power BI, Python, and machine learning, it goes to 6 lakhs. If you have understanding of cloud, Azure and all, they're free. Videos are available. You can just do it. Certification exam also 4,000 rupees or something is there. You can take the certification.
Maybe we can get.
So your salary will go up by 2 lakhs. That's all it is. Now it is all skill based payments. In data, it is all skills. I know R also. I can do R also. Another 1.5 lakh it will go up. So that is how is happening in industry. When I say no, you should be able to. That is what they will see. Are you able to deliver? So simply I know doesn't mean that they will not. They will evaluate. Okay, like one student, he asked them to build. They asked them to build more Python and R. Same model. They asked him to build on Python. Same model they build on R also. Because he said I am both good in Python plus R. They said if you really are good at it, we will give you a higher pay, pre-processing everything. Whatever he is doing, do it in Python. Also do it in R. One guy same thing. Do it in Power BI. Do it in Python also. They said, do it in Power BI. Do also in same visualizations, you do it in Python. Now, why Python? Because Python is zero cost. Power BI license is 1,25,000. So companies will think like that.
Like,
Seaborn, Matplotlib,
not that place.
ggplot2.
Not that easy.
See, once you understand the syntax or once you understand the functions. See, Power BI now we are saying it's easy. 3 years back, Power BI. DAX functions. For average also we used to write a DAX function. Quick measure is equal to, you used to write DAX function. For year to date, year on year calculations, we used to write DAX functions, Power BI. Now everything is automated. Even if statement is automated in Power BI. Add column, conditional statement, if give the variable name, what thing and all you can do it there. But earlier 3 years back, we have to write if statement on add column. Add column, calculate if variable name greater than, we used to write a full DAX function. Now Power BI is automated. But we know, right, how we work. When I started working in Excel, there was no average function also. We used to write a VBA code. This is how 1999 those days. When Excel was very, for everything we used to open a VBA window, a VBA programmer will sit and then we'll write it. No YouTube, so it's nothing. This much big book used to be there. From that book, we used to turn pages, type and get it. Get an error, call the customer call center of Microsoft, and then they will send a mail. No screenshots also. We can't take screenshots those days. Screenshots all came back after 2001, 2002. We have to explain it. That guy has to understand it. And then he has to send a solution to us. Then we have to put it in VBA. Those things used to happen 90s. After 2001, the Y2K problem happened. Na? After 2001, everything changed. And 2006 Excel, all the basic functions came into automated. And 2014, 17 and 20, fully automated Excel. Even VLOOKUP is also now fully automated. It will suggest which column to take, what to do and all. So, full automation. So you guys are lucky when you are looking at things. Python also. When I first opened Python, there was no Jupyter. It was Spider. You might have seen in Jupyter notebook. Spider will also be there. Oh, so much of problem with Spider. It hangs. It runs the whole code. If you don't put the splitter, it runs the whole code. You type one line and run it, it runs the whole code. Oh. Then came Jupyter and okay. So we'll continue tomorrow. If you have time, try doing it. Sneh, I'll tell you. I'll send in let me reach home. Okay, I'll give you.
Okay.
This is the